given the time, I'd like to introduce you to our attendees. So this is Viktor Gamov for you who are joining. He's a developer advocate at Confluent, and he can help you with all your Kafka and stream processing questions and needs. He stepped in for us as a last-minute speaker at Scalalove. Thank you so much, Viktor.
Last minute replacement, but hopefully it would be valuable addition to this awesome conference.
You're definitely a valuable addition.
All right. Thank you so much. So good morning, good afternoon, good day for everyone. For me, it's morning. For some of our attendees, maybe it's some different time of the day, but this is still doesn't matter because it's an awesome conference and we're online and it's all about, things. My name is Viktor Gamov. As was already mentioned, I work as a developer advocate at Confluent. And the Confluent is one of the companies who contribute heavily to Apache Kafka project. And we build our own packaging of Apache Kafka called Confluent Platform. Another important thing, if you want to know about me, I build highly scalable and highly available hello world applications. So essentially it. Now, today I'm going to be talking about a very cool project. It's not new, but not many people may be aware, and maybe it's not 100% translated to your existing knowledge with Scala. This project was built with a different type of audience in mind, like not the audience who know how to code, but rather audience who want to solve some of the problem, specifically stream processing problem. So let's dive into these different bits of this stream processing problem and why we need to have a thing called ksqldb. So Apache Kafka is open source and event streaming platform, distributed system that allows you to do multiple things. Many people start Kafka as a kind of like one of the better version of messaging, but this is kind of some of the more like overlook for the people. Once the people start looking deeper, Kafka can actually offer much more features. Essentially, there's three major components that Kafka is built on. Obviously, it's a client library that allows you to interact with Kafka. So essentially, there is the broker itself, and there's a client library that allows you to interact with. Based on these client libraries, the Apache Kafka community builds a couple interesting things. It's connectors that allows you to connect external system to Apache Kafka without writing code. And the stream processing capabilities, which is part of Apache Kafka as well. So like what is the stream processing? Let's talk about this. So like imagine we have some enterprise and you need to perform. Historically, Kafka was a place like it would behave as a kind of like a dump pipe, like people just getting some of the readings from some systems. They put them in Kafka because Kafka able to provide this kind of a very large distributed buffer in order not to overwhelm a receiver system where say we have some enterprise where we're collecting some information from like the telemetry from some sensors from some machines, and this is like example of one of the message. How does the message look like? There's like production line. There's something that this production line is producing, some of the widgets or some of the things, and we can calculate some interesting like. We potentially might get some of the interesting insights from this data, like especially when there's a large enterprise and large of amounts of messages are flying around. So it's not only that we need to like push it somewhere. Historically, Kafka was created as a pipe, like for a fast ingestion for Hadoop. But like, can we do better here? So I'll give you an example, like very short example that explains a essence of stream processing. So like remember this message, this particular like event that happens here. So say we have a stream of events. What is a stream of events? A stream of events is a sequence ordered immutable events things that happen over time. So immutable means that like once things have happened, we cannot change anything with it. So only thing that we can do is to send another event that helps us to like amend, and it would be up to the system that will be, you know, responsible for consume this message. So think about this. You have a conversation with your significant other and you said something that you're not supposed to say, and you cannot change things, right? So you already did this. The only thing that you can do is just like try to you know, make it up. So you try to come up with another message, and it would be up to receiver system to, you know, receive your apology or not. So this is how the streaming system is actually model real life very naturally. So things that happens in the real life, we don't have a time machines right now, unfortunately. Hopefully we'll have in future, but for now we don't have it. So we will model our system with this like immutability in mind. Now, so imagine we want to do some filtering of these events that happened. Like we have the red widget and yellow widget. So in the original stream, we have all sorts of combinations. Some of the events happen on this production line. Now, and we want to produce another stream. We're not modifying existing stream. It's always creating something new, which is like very functional approach to things, right? So we not mutate things in place. We're just like creating something out of it. So we derive from the initial stream of widgets, we create the stream of red widgets. So traditionally, how we can do this, we use Kafka Streams framework. Kafka Streams framework, it's a part of Apache Kafka, and starting from like last year, now there's official Scala API that allows you to write your Kafka Streams applications with Scala. But can we do better? Like it still requires the code. It still requires solve the problem about distribution code, deployment of code, supporting the execution. So you need to figure out where you're going to be running. You're going to be running this on a bare metal. You're running this in cloud somewhere. You're running on Kubernetes. You're going to run this on Docker or Mesosphere or whatever. How about this? So this is actually your stream processing application that does exactly as the previous line of code does. But in this case, it allows you to focus on something familiar. Many of us know what the SQL is, and many of us it's more domain specific than like a general purpose programming language that allows you to perform this kind of stuff. So let's get back to the initial example of this production line, and let's see what kind of stream processing application we can come up with, just giving this like a data model in mind, using this the purposely built language that is very much SQL-like. So there's two types of stream processing capabilities. One is the stateless stream processing, another one is stateful. So stateless stream processing is something where you don't need to know or you don't need to remember a previous step. Any type of transformation, any type of filtering operation, it is a stateless stream processing. So here's an example how we can use this select statement where you can do just simple filtering. Say you want to just get another stream of widgets where is weight of particular widget is more than a certain number. So we can filter this and produce another stream, and based on that we can generate another application that would be either alerted or something. So the result is going to be, in this particular case, we just will print out this on the console. We don't do we're not creating new stream. So the second thing is that we have a stateful stream processing. Anytime you need to do like accounting, summing, you need to perform any type of aggregation. So in this particular case, we need to remember previous state. Historically, how we can do this, we can perform this computation, and after that we save our state somewhere in, say, distributed database or whatnot, where we can access to this one. In this particular case, ksqldb already have state storage, so you don't need to worry about this. You just need to perform this count, and the ksqldb will take care of it. So we can also perform more complex aggregation. Like this particular case, we can calculate average temperature in Celsius, where the sensor, the information that reported for a particular sensor in terms of temperature would be more than like 20 degrees and stuff like that. So in this particular case, we need to have a storage for aggregating things, and after that we need to have ability to extract the kind of thing. And most important, not the most important, but one of the important things is just like how we can integrate with other systems. So ksqldb able to not only do this computational bits, but also communicate with external system and offload this result. So you can read the data from somewhere. Say we have a Kafka producer that writes data into Kafka. You do performing this calculation. After that, you dumping this result as in a form of report that like front end will be able to pick up. So this is a architecture of ksqldb, which is again event streaming database. It's open source. It's available at ksqldb.io. Works with any modern Apache Kafka installation. So it allows to integrate different storages, different applications, perform some of the, in my opinion, very complex things with very low kind of like effort in terms of writing code and things like that. And it also supports two types of queries. You can get the push queries that will be kind of have an updated result, but also you can have a pull query like a traditional database when you can just request something and you get like materialized view on particular data set. So we have an input source, everything or streams leads to Kafka. We start things with Kafka. We have some like a client application, or there's some connector that pushes data into Kafka. Once it's in Kafka, ksqldb can read this. Also, ksqldb internally use Kafka for some of the some of the storage information, some of the information about even like a processing. Even ksqldb stores this like execution log inside Kafka. It enables like multiple different use cases you can perform, not only like the calculation of incoming stream, but it also allows you to perform so-called like a joint or like enrichment type of application. So you with one ksql query you can access to multiple stream at a time, and you can perform very complex things. Now analytics is one of the use cases that this enables. Microservice communication, this is something that you can easily implement with ksqldb using this kind of like a pull query type of functionality of application. Let's quickly take a look on a demo and what we're trying to do here. Actually, you can participate in this demo. I will have this running. So essentially, let me talk this one a little quick. I will execute this for now, and I will explain what we're gonna see right now. Now, so I do have a connector to Twitter. I think it's a pretty important data source that I can read the data from. So I'm reading data from Twitter and putting this in this Twitter topic, and after that I'm massaging this data a little bit. So in this particular case, like let's replace it with Scalalove. So if you will be tweeting something with Scalalove, and within this say 1 hour window, my application should count. If you tweet more than 4 tweets within the 1 hour, you should be able to see your application, your result. So in order to see me this, let me reset this offset a little quick and see if we have any results. If some people were tweeting about this conference. So if people not tweeting, having this Russian heritage, and I can create bunch of fake of Twitter accounts that will be tweeting about this. So let me see if I will be able to tweet something. This is my, let me see here, out my small Twitter, what's up, Scala, hello, Scalalove, and let's have it here. I will tweet it here. Obviously, result will not be here because those previous tweets came from the different times. But if I will do part 2, and I'll do say part 3, and I suppose should see the stream here in a few more seconds. Let me do one more. Okay, part 4. We should see this streaming result in a moment, but let me quickly show you what we're trying to do here. So first thing that I'm trying to do is once I get this information from the Twitter, it comes in a JSON format. Now I need to transform it into something that will have a good format. In this particular case, it will look more tabular thing. So ksqldb supports some of the functions. In this particular case, this function can understand JSON path and extract certain things from the JSON. And the JSON is a native data structure here in ksqldb. Also, Avro and protobuf, those data structures are also native. So next thing is that, if I want to calculate some I will execute this continuous query that will constantly be writing data into console. Now I'll talk about tables and streams in a few more seconds, but in this particular case, this is where I'm creating this aggregated store where my results, like a user count, will go into this particular table. And here I also creating another table from my previous result that I will be just limiting by number of accounts. Let me see if my tweet bot is still tweeting. Maybe I already my API exceeded the search queries that I have. Let me see if I do have anything here. Select if actually data coming into the system. Where is it? My let's create. Nope. Okay, let me see. Up, fat fingers. Okay. Am I have a full screen? Let me see. Yeah, my window here. So let's see if we will be able to. No, not this one. I have a different query. H4. Come on. Okay, let's see. From Twitter, where text is Scalalove, and let's see if we have anything here from initial tweet, or if I don't have any data, meaning that Twitter already banned me. No, something is going on. Someone is tweeting, so looks like the thing is actually working. Let me quickly re-enter, because if I changing this window size, the console applications, they don't behave very well. Okay, let's try this once again. So when I add this image changes at the end, so it will create continuous query that will constantly pushing these results. In this particular case, nothing. If there is no new data, there's nothing's gonna have here. If I will say, okay, live from Scalalove, I should be able to see this tweet over here, I think, hopefully. Yeah. So essentially how it works, the Twitter, I tweet in Twitter, Twitter provides this Firehose API my ksqldb connector listens to data from this tweeter, gets this data into Kafka topic, and after that I can perform all sorts of operations on this data. So you can try this yourself. This demo will be available. I will show you after. Now, quickly. So as you saw previously, I use the console to interact with ksqldb as the like CLI, the same way as like SQL Plus or something like that or like a PG client that you use for interacting with any databases. You can do this in console. We do have a like UI that allows you to interact with this in kind of like a graphical graphical form. Let me show you real quick. So if I do things like ksql, this is my ksql server. I can see how many streams I'm running here. This is our Twitter stream with some data. I do have some tables that will preserve some of my aggregated queries. So I can go ahead here and just do something like query stream. So maybe my connection is down. Yeah, so I'm running this in the cloud. Maybe my local proxy just fall down. So this is why I prefer console. Console works all of the times, like the UI. So next thing, for the real programmers who wants to interact with this in a programmatic fashion, you can have a REST interface where you can just like submit query and get the results like almost instantaneously. And this right now, the team is working on providing like a ksqldb client, like a native client with like all cool features in terms of like reactivity and other stuff. Using maybe HTTP 2.0 as a protocol. So we have this enhancement or improvement proposals process, and one of this is kind of like community process where the people can discuss and influence some of the developments of the things. Okay, let's see what else we can do with ksqldb. So let's figure out. Let's pretend we have some of the data that represent some of the orders information, so we can perform some of the transformation and say we want to filtering, so transform this timestamp into something and throw some of the address data. So we're creating new stream from existing string, but just eliminating the fields that we don't need and keeping the fields that we do need. So in this particular case, you see we're querying the original stream and extracting this data that we only need. So in this case, new stream will not have this like information about the orders. We're creating the new stream where we have only things, but also you can see here there's a function that we can execute on particular fields. In this particular case, we extracting the timestamp on the previous stream and creating this raw time, which is like service column that would be part of new stream that will be used as a kind of like a time for new stream. And we're applying function the timestamp to string, so we can define a format how we want this look like. So in this case, in the result, it looks like this. So it's pretty powerful. In this case, you don't need to write a code to do like simple things like this. So let's talk a little bit about joins. Like usually when we're talking about some of the stream things, the first thing people are asked, like, can we join? So imagine we have some information about orders, and we do have some of the lookup table that allows us to get extended information about certain items. So in this particular case, we do have the item in our lookup table, and here we do have some of the additional information about so this is order information. Now we want to have an enriched stream where we can combine information about item, not only putting this item ID here, but also we can not item ID here, but also like include this information about make and model. So with ksqldb is actually fairly easy. Joins is like a natural part of it, and your previous knowledge of database joins are not disappear, so you can still use the same similar constructs over here. And we will have an enriched result here in this part. Oh, sorry, there's a pointer. Yeah, so we'll have a kind of like a joined flat structure of the ksqldb. Interesting thing here is that ksqldb able to integrate virtually from any source and sync system in the world, thanks to a very rich Kafka Connect in infrastructure, or like Kafka Connect ecosystem, where we can use this source connector that will read data from, say, in this particular case, from MySQL. Just in this SQL query, which is defining this create source connector, we specify the class connector that needs to be in the class path of ksqldb, but next stuff like ksql will start pumping data out of MySQL. Once you're done, you do some performing some queries and things like that, and after that you sync this out to another system, into Elastic or whatnot. Let me briefly talk about the streams versus tables and how they would be relate to one another. So we have a Kafka topic with certain events. So in Kafka topic, all events are immutable, and putting them. So we are creating these abstractions that called ksqldb stream that will have information about topic, plus it will partially create a schema for this, because S in ksqldb stands for structure. So we need to have this kind of a structure. A table in ksqldb will be able to, with the table, we are creating a current state for particular topic, for a particular topic or for a particular key. So in this case, if we go in like receiving new messages into Kafka topic, this is how the stream and table would look like. So in this particular case, we're creating a stream with only one entry. So in this case, we will use the event timestamp as our time, and our table will have a key and value. Next thing, we're putting another message into Kafka topic that will append to ksqldb stream, and also it will change the state. So think about this when you're performing this type of operation. It's like you are playing in chess, and you either see this board represents you a state of the world. The board is itself, it's your table, and if you're recording all these moves that you're playing around, this is your stream. So table represents a current state, stream represents how the things are changing over the time. So in this particular case, in Kafka topic, we have four events. If we create a table, that will have aggregate, and it will contain latest and greatest value for particular key. So under the covers, everything builds on top of Kafka producer and consumer. It's like foundational API that like we use everywhere. But with addition, that's not good. So ksqldb builds with Kafka Streams as a framework to implement certain internal things. It uses RocksDB as a storage for the data. That's it. So it's another application. It doesn't run inside the Kafka. You can run this anywhere. You can run this next to your Kafka cluster. You can run this in cloud. We have this managed Confluent Cloud thing that allows you to run like a serverless stream processing application, and you can run the ksqldb there. You can run this any type of, like virtually any type of hardware where you can run Linux and Java potentially. There's different packages, Docker, Kubernetes, whatever. So how you can scale this? You can scale how you can scale Kafka consumers, because it follows a same paradigm that Kafka consumers and consumers provides. You can run purposely cluster per your particular application, so you can have some sophisticated jobs that require you some big aggregations. You can run this in larger ksqldb cluster. If you have some other things like bigger or smaller, you can run this in a different size of cluster. Now, so the web UI allows you to quickly, map up your query, but like you can submit your queries and submit those in the same way as you can submitting to application server. You want to learn more, obviously. There's only one place that you need to go. It's developer.confluent.io. Like all your needs in terms of learning how to do stuff with stream processing, with Kafka Streams, ksqldb. There's Kafka tutorials, fantastic place. So you can take the use case, and after that you see how this use case implemented in the different stacks. If you have any questions about stream processing, join our Slack, which is cnfl.io/Slack. And as kind of special for today's show, we also giving away the stream processing books, Kafka Definitive Guide, Making Sense of Stream Processing, the fantastic books that I'm returning over and over. So those are great. Don't hesitate to praise me in Twitter and follow me in Twitter and ask particular questions. Thank you so much for being with me this time. And I think this is all the time that I have today. And I think we do have some time for some questions, do we?
I think that we'll have time for questions in the Q&A room,
okay.
But unfortunately not here. But thank you so much for your talk, Viktor.